Hello and welcome back to Honors Bio. So we've talked through how natural selection works. We talked through the steps of natural selection, why variation is important, how do adaptations help, all of these things. We've covered how natural selection, this theory of it started with Darwin and his finches and the different sized beaks that were perfect for each environment. Talked about all these things. But what we haven't talked about with natural selection yet is, well, what gets selected? Like what traits get selected for? Yeah, this whatever traits best suited for that environment, but what kind of ways do those traits get, selected for? And in terms of that, of like what traits get selected for, the traits themselves vary depending on what species. But the trend is that there's three basic types of natural selection. There's directional selection, stabilizing selection, and then disruptive selection. And we'll talk about, and that's kind of the point of this video, is we'll talk through each of these three different types of selection. So if we talk about the first one, directional selection. In directional selection, we talk about one of the extreme variations. That's what natural selection favors. So natural selection will favor one of the extreme variations of a trait. There's two examples here. We got peacocks. So male peacocks have this beautiful fan of feathers here, and that's for a reason, right? Females prefer males that have larger, brighter tail feathers. So males that have larger and brighter tail feathers are going to reproduce more often. Well, since they're reproducing more often, their traits, that adaptation of having that large fan, is going to just keep getting passed on and passed on and passed on, and bigger and bigger and bigger tails, feathers, later down the road. We saw the same thing happened with horses too. In horses, so this was the initial kind of distribution of horses, right? This is what the size originally looked like. But over time, again, the bigger horses just got kept to get selected for again and again and again and again. So over time, the size of the horses got bigger and bigger and bigger, right? So that's directional selection. We're favoring one extreme over the other. So this is just what that is. So the dashed line shows you just what the normal distribution should be of the original population. But then after natural selection has occurred, the distribution has shifted to the right? We're pushing it in one direction. So that's directional selection. Is that how we favor one extreme over the other? The next type is stabilizing selection. So with stabilizing selection, the opposite's true. With directional, we favor one extreme over the other, and the average is just not good. In stabilizing selection, we actually favor the average, and the average is good in stabilizing selection. We see a lot in human infants and babies that are born. If they're too small, that's bad because they haven't developed properly. Something's wrong there. Not gonna have enough blood or oxygen flow. All these things are bad. If they're too large, that's also bad because if they're too large, then there's gonna be problems when the women go to give birth. They may not, it's a whole mess if they're too bad. But average is good. 7 to 8 pounds. It's great. It's perfect. So the average, so that's just that selection again and again for the average is good. Birds, especially robins, their clutch size, so a clutch is just how many eggs a bird lays, it selects for the average. The average here is 4 to 5. if a robin lays too much or too many eggs, so more than 4 to 5 eggs in their clutch, well, then there's not going to be enough room for the birds, and birds will actually push themselves like out or push each other's out of the nest when the babies are born. That's not great. Too few, if you only have 1 or 2 eggs, well, that's not great either, right? Because we have to ensure that the offspring survive. Well, if you only have 1 or 2 kids, that's not a great odds of survival for a bird. So they learned that, well, if I lay 4 to 5 eggs in a clutch, that's really good because it's just enough to make sure that I have 1 or 2 offspring that are going to survive to adulthood and pass on these traits, but it's not too many to where then the offspring in the nest are going to be fighting over each other. So if you look at it in terms of a graph, this is what stabilizing selection looks like. Stabilizing selection is we're selecting against both of the extremes here. So we're selecting against both sides. So then the average becomes the more common variation that we see here. And we see less and less of the extremes because they don't get selected for, right? They're not surviving to reproduce and move on with their genes. So directional, we favor one extreme over the other. Stabilizing selection, we do not favor any extreme, we favor the average. Then we have disruptive selection, which is kind of the in-between of the two a little bit. In disruptive selection, we favor individuals on both extremes, but not the intermediate or the average individuals. So the individuals on either side of the extreme, either small or big or more or less, the extremes do well, but the average, the organisms in the middle, they have the disadvantage here. We see that in cuttlefish. So in cuttlefish, now this is a cuttlefish, if you've never seen one before. It's a type of squid. Why we call it cuttlefish, I'm not real sure, but hey. So in cuttlefish, being large in a male is an advantage because females prefer larger males. So the females are gonna choose the large males over the smaller males. So the larger males reproduce more often. So they get to reproduce and pass on their genetics and their genes down the line and keep having large cuttlefish in the future. But being small is also an advantage because being small for the cuttlefish, small males actually can impersonate females to lure the females in close to them where then they can reproduce with them. So we have this selection of the extremes. Being large is good because females would prefer to mate with large male cuttlefish, and being small is also beneficial to the small male cuttlefish because then they can impersonate females and then also be able to reproduce and pass on their genetics that way. So in terms of like that graph, what does that look like? Well, here we select against the mean, we select against the average. So either extreme is going to be favorable over just the average. It's not in disruptive selection, it's not good to be the average. But we talk about either being too small or being smaller or being larger. That's what disruptive selection is good for. So there you go. So the 3 types, we have directional selection where we favor one extreme. So we favor one extreme over the other. You have stabilizing selection where we select against the extremes, so the average is great. And then we have disruptive selection where we select against the mean, we select against the average, so both extremes do well. So that's it for this video. Let me know if you have any questions, and I'll see you in class.